I'm going to try and play the game. Which problem did you struggle with? Here we go. Let's try number 9. Number 9 is 1.313 repeating. So I look at this and go, well, wait a second. How do I write the first two together? That would be 13 over 10, right? Plus the next one would be 13 over, what would it be, 13 over 1,000, right? Plus 13 over, since that's 2 zeros, I have 2 more zeros, so boom, like that, 100,000, plus 13 over 100,123,12, and I put some commas in and call it a day, plus dot, dot, dot. Or I could go 1 plus 31 over 100, plus 31 over 1,000, plus 31 over 10,000. Theoretically, I should get the same answer either way. Wait, I need another 0 here, though. My bad. Nope, I don't. Yes, I should. All right, 100,000. And you're like, well, those don't look the same at all, so let's try this out and make sure they do get the same answer. So look at this first problem, and I would go, all right, so my ratio is 1 over 100. It's what I'm multiplying to make the next term, right? So my ratio is that. If I don't know the ratio, by the way, I do 13 over 1,000 divided by 13 over 10. Flip and multiply it 13 over 1,000 times 10 over 13. 13's cancel out. I get 1. I get 10 over 1,000, which is 1 over 100. So my ratio is 1 over 100. That's less than 1. So then I would go A1 over 1 minus R is my sum of my infinite series. The first term is 13 over 10. After that, it's 1 minus 1 over 100. So that gives me 13 tenths over 99 over 100. So I flip and multiply, I get 13 over 10 times 100 over 99. And I get something ugly. I get 130 99ths, which would be 1 and 31 99ths. So far, so good. Try the other way. The exact same thing. I plot the 1. It's not part of my series, right? So I would go, my ratio is going to be 1 over 100, same logic. I go, the sum of my infinite series is A1 over 1 minus 100. Sorry, 1 minus 1. What am I doing? Hold on. A1, 1 minus R. So my series would be the first one, which would be 31 hundredths over 1 minus 1 over 100. So I get 31 over 100 over 99 over 100. I flip and multiply. I get 31 over 100 times 100 over 99, which gives me 31 over 99. Remember, I got to put the 1 back in, and I get 1 and 31 99ths. Same answer either way. Which way is better? Whichever way you like is better. Next one, let's talk about number 12. Number 12 is what I want to talk about? Yes, I want to talk about number 12. Number 12, that would be 3/4 plus 15/8 plus 75/16. Oh yeah, plus dot, dot, dot. So get the next term is 5 over 2. Oh, my ratio is 5 over 2. This is infinity and I'm done with the problem. What? Yeah, that's the way you do it. How about 14? 14 is 100 plus 90 plus 81 plus dot, dot, dot. I'm making sure this thing looks like a geometric series, so I check it. If I find my ratio is 90 over 100, which would be 9 tenths, okay. And then 81 over 90, which is 9 tenths when I divide both top and bottom by 9. So I do have a common ratio. It's 9 tenths. 9 tenths is less than 1. All right. So I'm going to go ahead and use my term. The sum of an infinite series equal to A1 over 1 minus R. First term is 100. 1 minus 9 tenths. Working it forward, I get 100 over 10 minus 9 tenths, which is 100 over 1 over 10. 100 times 10 over 1, which is 1,000. And if you were to have that series and play with it long enough, you'd eventually realize you're getting closer to 1,000. It's worth doing once just to see how it works. We're not going to do it now. Let's talk about the physics problem at the bottom, which I don't know what it has to do with physics, but we'll try it anyways. So let's find the first 7 terms of an infinite series representing the vertical distance traveled by the ball. So 55 goes down, bounces, comes up 33, goes down 33, goes up whatever this is. I have to figure that out. Now I've got my pattern, right? So it would be 3/5 of 33. I get 19.8 and then 19.8. Now, it's a little tricky because I got these pairings, right? If I were to look at it though as 55 plus 33 plus 19.8 plus dot dot dot, I could figure out the first 7 terms, and I could do the second one with 33 plus 19.8 plus, and now that's not interesting. So what I would like to do is I'd like to instead do the series like it should have been done, which is 33 plus 19.8 plus dot dot dot, which is probably the way you did it because you're math people, not actually thinking about how a ball bounces. And so I should take a look at this and go, how do I do this problem? All right, well, 3/5 is what it's bouncing. That's my ratio. I've got 7 terms. I'm going to go ahead and do it the way I'm supposed to, which is A1 minus A1 r to the 7th all over 1 minus r. So I put in the first term as 55 minus 55 3/5 to the 7th all over 1 minus 3/5. So I start to put this together, I get 55 minus 55, oh Lord, this is going to be fun. 3 divided by 5, which is 0.6 raised to the 7th power, and I get 0.02799936 all over 2/5. Multiply that by 55, and I get 55 minus 1.539648. Divided by 0.4, so 55 minus that. Gives me 53.460352 divided by 0.4. Divide that by 0.4, and I get a lovely 133.651. Probably should bother with decimals, fractions, but I'm not going to at the moment. So far, so good? All right, then the next thing is what's the total vertical distance traveled by a ball before coming to rest? Wait, what? When does it come to rest? How many bounces? Well, we could take it to infinity, can't we? It's got 3/5 for ratio, so we could do the sum of the infinite series. That would be A1 over 1 minus r. First term is 55, 1 minus 2/5. And 55 over, not 2/5, it's 3/5, my bad. 2/5, flip and multiply at 55 times 5 divided by 2. So for an infinite number of terms, 55 times 5 divided by 2, I get 137.5. So it's not bouncing much here at the end because it only covers another 4 or so meters after that. Feet. Good? Alrighty then, let's start working on the next worksheet. Here we go.